In this question, we will solve d square plus 4d plus 3 operating on y is equal to e raised to minus x into sine 2x into sine cos x, into cos 2x. So solving for yc, when we solve the auxiliary equation, we'll get d is equal to minus 3 and minus 1. So yc is c1 e raised to minus 3x plus c2 e raised to minus x. This is quite straightforward. Now to find yp, we see that capital X is e raised to minus x into sine x into cos 2x, correct? So this is a product of three functions, alright? What we'll do first is, we will write the product of sine and cos as a sum. So I hope you remember sine A cos B is sine of bracket A plus B plus sine of A minus B divided by 2. So applying the formula, I'll get sine 3x plus sine of x minus 2x, which is minus x divided by 2. Now multiplying e raised to minus x inside, I'll get e raised to minus x into sine 3x divided by 2, and this sine of minus x becomes minus sine x, so that's why this is minus e raised to minus x into sine x divided by 2. So this looks like x1 minus x2, therefore yp is yp1 minus yp2. So yp1 is 1 upon f of d operating on the first function. Okay, this was your x1. So you see that over here I have 1 upon f of d operating on product of two functions, of which one of them is e raised to minus x. So this reminds me of case 5, which is e raised to ax into v, where v is either sine or cos. In this case it is sine. The value of a is minus 1. It comes from e raised to minus x. So applying the formula for case 5, which is e raised to minus x into 1 upon f of d plus a operating on the remaining function v. So f of d is this, so d plus a will be d plus minus 1, which is d minus 1. So when I solve this, I get d square plus 2d. Okay, so my yp is half into e raised to minus x into 1 upon d square plus 2d operating on sine 3x. Now I see that it has reduced to case 2. Now my sine ax plus b is sine 3x. So my new a is 3 and my minus a square will be minus 9. Okay, so wherever there is d square, I put minus 9. So when I do that, I will get half into e raised to minus x. Now notice that the e raised to minus x has to be continued on the left hand side only, because as per the formula, e raised to minus x is on the left hand side of the operator. So e raised to minus x into 1 upon minus 9 plus 2d operating on sine 3x. So this becomes 2d minus sine. Now you know very well, for sine and cos, you cannot substitute for d, you have to substitute for d square. So we multiply and divide by the conjugate of 2d minus 9, which is 2d plus 9. So in the denominator, I get 1 upon 4d square minus 81 operating on sine 3x. So we get half into e raised to minus x into 2d plus 9 into 1 upon this, in place of d square I put minus 9. So I'll get this constant operating on sine 3x. So we see that this constant into 2 becomes minus 234. So I have 1 upon minus 234 e raised to minus x into 2d plus 9 operating on sine 3x. Now you know very well that d in the numerator simply means derivative. So 2d plus 9 is 2 into derivative of sine 3x, which is 3 cos 3x plus 9 into sine 3x. So this is your yp1. Similarly, your yp2 is also 1 upon f of d operating on this, and I see that again I get case 5. Here I have not written any comments because again it is case 5. So I just continue as in case 5. Okay. So I will get the same, because the value of a is minus 1. So I'll get the same f of d minus 1, which will be d square plus 2d. And only difference here is the value of a when it becomes case 2 is 1. So minus a square is minus 1 square, which is minus 1. So if in place of d square, I have put minus 1. That's why you get 2d minus 1. Okay. In yp1, in place of d square, I had put minus 9 because the value of a was 3. So minus a square is minus 9. Here the value of a is 1. So minus a square is minus 1. Therefore the difference will only be in this step. Now you solve as usual. Multiply and divide by the conjugate of 2d minus 1, which is 2d plus 1. And yp2 will be this, and finally you have yp is equal to yp1 minus yp2. I get a plus sign here because my yp2 is negative, so minus minus becomes plus, and your final solution y is equal to yc plus yp.